Phoenix Vision. Sound.
Are there any questions?
Yeah, let's just go step by step about how to do this vector addition. That is a
I mean,
wonderful.
I don't mind talking about it, but
You don't want to see.
The whole time, yeah.
is the confusion on the graphical addition or on,
Yeah.
okay, not the not the analytical?
Yeah, it's the graphical. Graphical is confusing to me. I don't know why. I've done it before.
All right, are those the same number?
Yes.
Yes. Wait.
Oh wait. Come on, don't. Yeah, that's because it's a positive.
Yes.
Yeah.
Okay. I was just wondering, philosophically, they're the same number, or are they two different numbers that happen to have the same value?
Don't confuse us anymore, please. Like I can't do it. I can't.
It's 9:30.
All right, two vectors are considered equal as long as they have the same magnitude and direction. Whether those are the same number or different numbers with the same value, I think we would agree, if I put an equal sign in between them, that is mathematically viable. You want to debate that? You were hesitant. Trying to figure out what I said?
I think 2 is equal to 2.
Okay. I hope so. Another side note, when I took pre-calculus, there was a proof to show that positive 0 equals negative 0. So the question comes into my mind of, are these actually two different numbers that happen to be equal to each other? There's a PSAT question where that was the crux of it. If positive 0 and negative 0 were two different numbers, there was one answer. If they were the same number that happened to be equal to each other, there was a different answer. There were two of us in the class who were more math nerds than anyone else. We both had the same assumption that they were two different numbers that equaled each other, and both missed that problem because of that. It was not that I'm holding grudges, that are.
Sounds like you're pretty upset by that.
Yeah, I
There were a couple of really bad standardized test questions that anyway. So two vectors are equal to each other if they have the same magnitude and direction.
Okay.
So if I'm drawing that, let's just assume that they look like they're supposed to be in the same direction and supposed to be the same length. We will assume that those are equal vectors. So if I'm adding vectors, we'll just start out with two of them. All I need to do is shift one of the vectors to basically from the tail to the head. Just so we're in common language, that's the tail, that's the head. Pretty much like arrows in general. So I'm going to take this vector and I'm just going to shift it. So that vector and that vector should be the same. So if this is vector A and B, so that would be B right there. So the sum of A and B is, well, the sum of those two vectors right there. So it's from where I begin to where I end. So that is my resultant right there. Resultant, just the fancy word for sum of vectors. You can think about that the sum would be the shorthand. If these were, now in the lab, these were forces. If we were talking about directions to get someplace, yeah, I could go, 5 miles this direction, we'll just say 50 degrees, and then go north 4 miles. What would be the directions you would give as the crow flies? Well, it's the sum of the two.
Okay.
So if I've got more than two vectors, then I just keep the process going. So if I'm adding these three vectors, I'm going to start with one of them, and it doesn't matter which one I start with. The commutative property holds, the order of addition is irrelevant. I'm gonna start with this one just because of habit. So I've got this vector right here, and now I'm gonna shift one of them, doesn't matter which one I do next, I'm gonna shift this one so that it is now here. So this is 1, 2, and 3, or if you prefer A, B, and C. I now take my vector 1 plus my vector 2, I'm now here. I now take my third vector, and I shift it. There's my third vector right there. And my resultant, from where I started to where I ended. That is the sum.
I understand. I also just don't want to do it.
The first part, when you're doing it graphically, it is a tedious exercise. I understand that.
So, my other question is, I think I had confusion about what I was supposed to be doing with reference angles from the lab when it came to this,
Okay.
and so I wasn't sure.
The reference angle, so if we,
Was that?
this is the one thing that we don't have to redefine.
Okay.
0 degrees, 90 degrees, 180 degrees, 270 degrees. So I'm assuming 0 degrees is that way. Reference angle is, if I have an X and Y coordinates. So if I'm here, if that were my vector, if I looked at the X and Y coordinates, well, my Y is that distance right there, and my X, the absolute value of the X is that distance right there. Sure, why not Y X? That's a point X Y. If I wanted to figure out that angle right there, I just do the arctan of Y divided by X. And so if I do the arctan of whatever the vertical component is of the horizontal component, the absolute value of those, I'm gonna get my reference angle.
Okay.
And that's one of the reasons why I did the reference angle.
So that was literally just for determining the Y and X components, not for anything we needed to do graphically. I think my brain was trying to put somehow
In
connect it.
part A,
Yeah. I think
I don't have you breaking that up, do I?
I don't think so.
No, you only made us
Wait.
find the degree and the magnitude.
I
Because
think-
you have the magnitude is gonna be the weight of what was hanging off that string.
Yeah.
Newton.
The angle is whatever you measured on the table.
Yeah.
So,
I don't know why my brain thought that, I don't know.
That's the happen.
I'm gonna be honest, I have no idea.
and so just as to finish that up, the reference angle is towards the angle next to the x-axis. The actual angle is that or that. There are questions? This just seems very odd.
I know,
So,
it's so quiet.
Guess we'll just have to cancel class today. I don't want it to be canceled.
Then for you, you won't. Then there were 5.
Yay.
Or 6, I'm going to include.
So I guess regroup yourself.
Alright, so there's Robin. Okay, we got Joseph. We've got Margaret. We've got Thor. No.
Maybe people decided not to come because they knew the lab was due to.
That's a silly reason not to be here.
That used to happen in my biology class all the time. People would just not show up because they knew the lab was due. And then they'd come in the next day with it ready. This is very bizarre.
Alright, other questions? Pick up where we left off.